What if we swapped our sun with other objects in the universe? Imagine waking up to a dawn that never comes. No warmth, no light, just the cold, endless black of space pressing down on a dying world. What if the sun was gone, and in its place, something else? A neutron star, a black hole, a giant planet. What if we swapped our sun with another object in the universe? The sun, our star, 4.6 billion years old, a vast sphere of plasma holding the solar system together with its gravity and bathing our world in energy. It is not just a light in the sky, it is the reason we exist. But what if, through some unimaginable event, it vanished, replaced by something else? Today we explore that impossible idea. We ask, what would happen if we swapped our sun with other cosmic objects and see, step by step, how the fate of our world would unfold? First, imagine the sun replaced by a black hole. If it had the same mass as our sun, something strange would occur. Earth would remain in orbit. It would not be pulled in, because gravity depends on mass, not on the form of matter. The Earth would keep circling an invisible point of infinite density. But there would be no light, no heat. Without sunlight, Earth's surface would plunge into freezing darkness. Within a week, the average temperature would drop below freezing. Within a year, it would fall far below zero. The oceans would freeze from the top down, leaving only the deep interiors liquid. And life as we know it would end. Perhaps only deep ocean vents would still hold warmth. The sky would now shimmer with countless stars, brighter than ever. And at the center of the void, a faint halo where matter falls into the black hole. Our solar system would become a frozen monument, bound by gravity, but stripped of life. Now imagine we replace the sun with a neutron star, a remnant of a dead giant, no wider than a city, yet more massive than the sun. Imagine the weight of a mountain compressed into a spoon of matter. That is the density of neutron star material. If one replaced our sun, its gravity would be similar, but its radiation would be deadly. It would pour out X-rays and gamma rays even across the vast distance. Those rays would rip through the atmosphere and sterilize the surface in seconds. The sky would glow with ghostly blue light. No warmth, only radiation. The magnetic field would collapse. The ozone would vanish. The oceans would boil under invisible fire, and all life would perish. Earth would continue to orbit, but it would circle a star that glows, not with life, but with death. Now think of a smaller, quieter change. The sun becomes a red dwarf. These are the most common stars in the galaxy. Small, dim, and long-lived. They burn for trillions of years. But if one replaced our sun, Earth would be too far away to stay warm. Our world would freeze solid. To survive, we would need to orbit much closer, 10 times nearer than Mercury is today. Yet that closeness brings danger. Red dwarfs erupt with violent flares, sending radiation storms into space. Such a world would swing between warmth and deadly cold. Life could exist, but it would be strange, fragile, and different from anything we know. What if our sun was replaced not by a star, but by a planet, say Jupiter? Without the sun's mass, gravity at the center of the system would weaken. The planets would drift outward into the dark. Within hours, daylight would vanish. Within days, the cold would set in. Within weeks, the oceans would freeze solid. Jupiter would hang in the sky, huge and pale, reflecting only faint starlight. But without fusion, without energy, it could not save us. The solar system would fall apart, drifting forever through the void. And what if we replaced our sun with something vast, a red supergiant, 1,000 times larger than the sun? Its surface so wide, it would engulf Mercury, Venus, and Earth. Our world would be swallowed whole. Even if we were farther out, the light and heat would scorch the planet to ash. The air would ignite, the oceans would turn to steam, and the surface would melt into glass. And when the supergiant died, it would explode in a supernova, vaporizing everything that remained. So what makes our sun different? It is not the biggest, not the hottest, not the brightest, but it is stable, balanced. Our sun lives in a perfect tension, its gravity pulling inward, its fusion pushing outward. This balance has lasted for billions of years, allowing life to emerge. Too massive a star burns too quickly, too small a star flickers too faintly. But our sun sits in the middle, a perfect harmony between chaos and calm. It is the ideal star for life. If such a cosmic swap occurred, the sequence would be devastating. First, gravity would shift. Depending on the new mass, the planets would either spiral inward or drift away. Second, the light would change. Some objects would flood Earth with radiation. Others would plunge it into darkness. Third, the biosphere would collapse. Photosynthesis would stop. Temperatures would rise or fall beyond survival. Fourth, the atmosphere would fade. Magnetic fields would weaken. Surface life would vanish. And finally, the Earth would endure as a cold rock or scorched ruin orbiting whatever remained. Every step a chain of destruction, but also transformation. The laws of physics stayed the same, yet the fragile thread that makes Earth alive would break. In the scale of the cosmos, our sun seems ordinary. But in that ordinariness lies wonder. It burns at the perfect pace. It shines with the perfect warmth. It anchors a system where life can breathe and grow. Every sunrise, every season, every breath of wind depends on the sun's steady heart. Swap it with anything else, and that harmony is gone. Perhaps the most extraordinary thing about our sun is that it asks for nothing, yet gives everything. And somewhere in the darkness of space, there are countless worlds circling stars like ours. Perhaps they too look up at their suns and wonder what would happen if they vanished. Next time, we will ask another question. What if Earth stopped spinning?